here in chapter 4.2, and we're going to be solving systems of linear equations by the substitution method. Objective 1 is to solve systems of equations by the substitution method. Now let's go through the steps for substitution. Step 1, it says solve either of the equations for one variable in terms of the other. If one of the equations is already in this form, you may skip this step. So step 1 is to get one of your equations to say y equals or x equals. Then step 2, substitute the expression found in step 1 into the other equation. This will result in an equation in one variable. Step 3, solve the equation containing one variable. So it will be an equation only with x or only with y. And then step 4, you're going to back substitute the value found in step 3 into the equation from step 1, simplify, and find the value of the remaining variable. And then step 5, check your proposed solution in both of the equations to make sure the left side equals the right side. Alright, let's start with number 5 on page 294. And it says solve each system by the substitution method. And the system is x plus 3y equals 5. And 4x plus 5y equals 13. Now to use the substitution method, we're going to have to solve one of the equations for one of the variables. When deciding which equation to solve for, look for the variable who has a coefficient of 1 or -1. So this x has a coefficient of 1, so I'm going to solve the first equation for x. So we'll have x plus 3y equals 5. To solve for x, we're going to subtract 3y on both sides. And we end up with x equals 5 minus 3y. Now we're going to take this result, this x equals 5 minus 3y, and plug it into the second equation. So everywhere we see an x, we're going to put in 5 minus 3y. So this is going to become 4 times 5 minus 3y plus 5y equals 13. Now we have an equation with one variable, so let's solve for it. So let's start by distributing the 4, and we'll get 20 minus 12y plus 5y equals 13. Combine like terms, and we get 20 minus 7y equals 13. Now we need to solve for y, so subtract 20 on both sides. And we'll get negative 7y equals negative 7. Divide both sides by negative 7. And we end up with y equals positive 1. So now, with this result, with this y equals 1, come back up here to this equation where we had x equals 5 minus 3y. And we're going to plug in the y to solve for x. So we had x is now going to equal to 5 minus 3 times 1, which is 2. So x equals 2 and y equals 1. So the solution to this system is the point 2, 1. And of course you can check it by plugging it into both equations, and you'll see that the left side equals the right side. Alright, let's look at number 30. So now we have the system x over 4 minus y over 4 equals -1. And x plus 4y equals -9. Now before we start the substitution method, let's take care of these fractions. So to avoid fractions, you need to multiply every term by the least common denominator. So the least common denominator here is 4. So you're going to multiply everything by 4. So each term. And this equation is going to become, well, these 4's cancel out, and that just leaves you with x minus these 4's cancel out, and that becomes y equals negative 4. So you end up with x minus y equals negative 4. And then you have the equation x plus 4y equals negative 9. Now we can use the substitution method, and we can solve either equation. So I could solve the first equation for x or y, or I could solve the second equation for x. I'm going to choose to solve the first for x. So x minus y equals negative 4. To solve for x, I'm going to add y to both sides. And we get x equals y minus 4. Now we're going to take this and plug it into the second equation. So everywhere you see an x, you're going to put in y minus 4. So this is going to become y minus 4 plus 4y equals negative 9. Combine our like terms and we get negative 4 plus 5y equals negative 9. Now we're going to solve for y, so add 4 on both sides. And we get 5y equals negative 5. And then divide both sides by 5. And we get y equals negative 1. Now we're going to find x using this equation. This x equals y minus 4. So we're going to have x equals negative 1 minus 4, which is negative 5. So the solution to this system is the ordered pair negative 5, comma, negative 1. And again, you can check it by plugging this solution into both equations, and you'll see that the left side equals the right side. Now let's move on to objective 2, and we're going to use the substitution method to identify systems with no solution or infinitely many solutions. So again, let's go in our books to page 294, and we're going to start by looking at number 14. And we're still solving the systems by substitution. And for number 14, we have the system 6x plus 2y equals 7. And y equals 2 minus 3x. And remember, we're using the substitution method. Now, the second equation is already in the form of y equals. So we're going to stick here. So this is step 1. Y equals 2 minus 3x. This has already been done for us. So now we're going to take this and plug it into the first equation. So everywhere you see a y, put in your 2 minus 3x. So we're going to have 6x plus 2 times 2 minus 3x equals 7. And now we're going to solve this equation for x. So we're going to have 6x plus 4 minus 6x equals 7. Combine our like terms, 6x minus 6x, well, that's 0. They cancel each other out. So we're left with 4 on the left side. So now we have 4 equals 7. This, however, is not true. Therefore, the solution would be no solution. So if we were to graph these two lines, we will see that they actually are parallel. All right, let's look at number 15. Now we have the system y equals 3x minus 5 and 21x minus 35 equals 7y. And again, we're using substitution. The first equation is already solved for y. So we're going to start with y equals 3x minus 5. And we're going to take this and substitute it into the second equation everywhere we see a y. So we have 21x minus 35 equals 7 times 3x minus 5. Now we get to solve for x. So we still have 21x minus 35 equals, distribute the 7 inside, and we get 21x minus 35. Now notice that the left side equals the right side. However, let's keep working this out. So let's get our x's together. So how do you get 21x over to the other side? Subtract 21x on both sides. And these cancel, and these cancel. Now you're left with negative 35 equals negative 35, which is true. Therefore, what can you say about the solution to this system? You'll say that there are infinitely many solutions. So if we were to graph each one of these lines, they would lay right on top of each other. All right, number 21. Now we have the system 2 times parentheses x minus 1 minus y equals negative 3. And then y equals 2x plus 3. And of course, we're going to use substitution. So let's start by distributing the 2 in the first equation out. So if I distribute my 2, this equation is going to become 2x minus 2 minus y equals negative 3. And if I wanted to, let's go ahead and add the 2 on both sides. So now I have 2x minus y equals negative 1. So this is the first equation, and this is the second. Now the substitution method, the second equation is already solved for y, so we're going to use it. So we have y equals 2x plus 3. And we're going to substitute it into the second equation, everywhere we see a y. So we're going to have 2x minus 2x plus 3. Notice I had to use parentheses even with the minus sign here, because that's like saying negative 1. And this negative has to be multiplied on every term, so make sure you have your parentheses. And this will equal negative 1. Now let's go ahead and distribute the negative 1, so we get 2x minus 2x minus 3 equals negative 1. The 2x minus 2x cancels out, and we're left with negative 3 equals negative 1, which is not true. Therefore, this solution is no solution. Okay, objective 3 is now solve problems using the substitution method. And these problems, of course, will be word problems. So let's go again to our books, this time to page 295. And let's look at number 36. And it says, write a system of equations modeling the given conditions. Then solve the system by the substitution method and find the two numbers. And for number 36, it says, the difference between two numbers is 25. 2 times the larger number is 12 times the smaller number. Find the numbers. So with any word problem, the first thing you got to do is label your variables. So let x be the larger number. And let y be the smaller number. Now let's go back to the first sentence and let's try to write out their conditions. And it says the difference between two numbers is 25. So difference means subtract. So x minus y equals 25. And because this 25 is positive, I know the larger number had to subtract the smaller. And then for the second, it says 2 times the larger, which means that's 2x, means equals 12 times the smaller, so that's 12y. So here's your system. Now we need to solve to find the numbers. Now, of course, it doesn't matter which equation you solve for which variable. So for this time, I'm actually going to choose the second equation. I'm going to solve it for x. So I have 2x equals 12y. To solve for x, I'm going to divide both sides by 2. And we get x equals 6y. Now you're going to take this and plug it into the first equation everywhere you see an x. So we're going to have 6y minus y equals 25. So this means 5y equals 25. Divide both sides by 5. And we get y equals 5. So the smaller number is 5. Now let's find the other number by plugging it back into here. So this is going to become x equals 6 times 5, which is 30. So the first number is 30, and the second number is 5. So 30 and 5. Okay, so this will conclude our video for chapter 4.2. Please email me if you have any questions.